An announcement, Laura Sarnio from Nova School for Mathematical Dual will not be there tomorrow, this morning. So we'll start straight away with Aleksandra Ravas and Guido Ramellini. Erasmus Plus Project Team, meet Amy the Fox on a STEM quest.
Good morning to everybody. My name is Aleksandra Ravas, speaking here from Mathematical Society Archimedes of Serbia, together with my colleague Guido Ramellini from MACA, Museum of Mathematics of Catalonia. We are going to explain you who is Amy the Fox and what is she doing on her STEM quest. So first thing is actually that we are cooperating together on an Erasmus Plus project, which has this acronym SMEM, which means, as you can see, significant mathematics for early mathematicians. And I'm just going to add that in this situation, it's actually something that means something in Serbian. So when you say SMEM, that means I'm allowed to do something. So it is, as you can see, logo of this project is a little fox. Why is the fox and what is going on, we are going to see right now. So the project main idea is actually emphasizing this quote from George Polya. And we want to have something which is going to be aimed at kids, but it's going to be repeated during their schooling in different ways, so to help them easier grasp mathematics and learn how to solve the problems. So as I mentioned, project aim is just to have some let's say, materials for kids in the kindergarten, so and the ones that are actually in the first years of primary school. So it's going to help them to learn mathematics in an interesting way. We have here Amy the Fox, and we have here one of her friends, and in between them you have something which is actually like a challenge, because she needs to solve some challenges on her way to gather her friends and, well, I don't know, celebrate a birthday or something similar. So in this case, we are trying to introduce some physical exhibits which are going to be connected with a story and help the kids be engaged and learn something from playing in mathematical ways, because behind every of these exhibits, you have some mathematical concept included.
Yeah, that's the kind of development, the starting development of some of the exhibits. As you see, the materials is simple. You have to think about thought for 3 years old children and developing. So all the proposal accessible from the age of 3 stimulates important mathematical skills and can be further developed in subsequent school stages. There is not small mathematics. There are no small mathematicians. That's one of the theme of conversation groups in the Matrix in Barcelona. So we developed the idea in a physical way. Go on.
And these are basic building blocks of this project. So we are using 3 pillars. One is interactive museum technologies. The other one is joyful experience we want to ignite, and storytelling connections between those exhibits in order to make them, well, easy to remember, maybe. Okay. So this project is going to have three project results. The first one we are working right now is small exhibit. It's a small exhibition with, well, hybrid. We will explain in the moment what that means. Then we have this didactic suitcase, and the third result is going to be educator companion, which is going to be in digital shape.
So that is the development of the idea of the project in different parts. As you see, it's everything under constructions. At the end of this conference, we have the second meeting just to discuss the first physical exhibits for the physical exhibition. And so we will combine online and offline exhibition through playful and experiential methods to enhance children's interest and help them to develop knowledge and abstract thinking. In the evolutionary process of each exhibit, the components of the museographic language are being defined: format, design, communication elements, dimensions, materials, so that the user response can be quickly activated. Hands-on, minds-on, heart-on, and talk-on. The dialogue is fundamental.
So I'm just going to add that this part of the project is a hybrid exhibition because it consists of 6 physical and 2 digital exhibits. And here you can see the way we are sharing ideas. We have a Google Drive with these folders, and we put inside the oral communication and discussions regarding the individual exhibits. Okay, so for instance, this is just to show you how it looks like. It's one of the exhibits called Beaver's Dam. So obviously we have one of Amy's friend is a beaver. And this is how we started. Our first meeting was in Barcelona, and there we exchanged ideas with the aim of choosing what is going to be part of this first project results, so which exhibits are going to be used. It's also, in general, the idea of this project is to have all the materials open source. So we want to make proper blueprints in order to make it accessible to anybody, in the sense of that you can reconstruct these exhibits and make them from any material, I mean, depending on your situation. So this is going to just show you the way we were thinking and the way we are developing this exhibit.
So that was the first idea. The discussion was about how to put it in the history. So the Beaver Dam came before the first proposal of the exhibits. Obviously, a dam of a beaver is not an horizontal thing, but it's a vertical thing. So the idea was how to put it in the history, because we think that it's quite interesting. It's very important that there is a plot, an history that the children can follow, like in a tale book or something like that. And then the exhibit was transformed from horizontal to a vertical situation. And now we need to develop the scenography, where to put that one. But it seems a very simple exhibit. Obviously, the approach must be simple for 3 years old people. Now we are discussing about the dimensions, the weight of the pieces that you have to put one up each other. So that is the next step. Discuss how to produce exactly the exhibits. But behind the exhibits, there are a lot of good mathematics. And the idea that the square piece had to go in the center of the situation or of the construction of the building is not a simple idea. It's something that can be demonstrated with an high level of mathematics. Another one. That's developed that Albrecht Bettelsprachen made of the mathematical Gissen made about explaining. Of course, this part is not for children. It's not for visitors. It's for their educators if they want to develop in school or wherever the ideas, the mathematical idea that are behind the exhibits. The exhibit is starting a process, not to end a process.
That's going back to Polia's quote. That's the idea, to have this available in the later stages of their mathematical education, so you can return to something they already seen during their years in kindergarten. So it's going to be a little familiar, and then you explain mathematical concept behind it. I mean, in the later stages, it's going to be maybe more accessible to explain it when they already have some previous experience with this.
And as you see, it's quite easy if you want to transform it in a virtual hands-on experience. on a computer, or if you want to change the format and put it in the suitcase, in the didactic suitcase, that must be lighter and maybe bidimensional and not three-dimensional. So that's the list of the 5, 6 big exhibits that are in the big exhibition, but also there are some ideas that we had reached for the didactic suitcase. That is the project number 2. So have you see more than under construction, it is under analysis. We are just in the first step of the process, choosing the exhibit that we want to put in the suitcase, and starting from that, the adaptation of the story and so on, the materials, the dimension, and all that.
And as you can see, this third result is still pending because we need to finish first 2 phases in order to make this companion. This is going to help the teachers to help the teachers use all the materials we have prepared in the previous 2 results.
Obviously.
And at the end, we just want to list all the partners that are a part of this project. As the leader of the project, we have Imaginary from Berlin. I guess you already all know that they are trying to communicate the recent developments from mathematics to public, and their exhibit used to be physical, but unfortunately in the last 2 years they have to switch, which actually is on the other side, well, it's good for this project because now they have this experience with digital exhibits, which is going to help us include them in the project results. The second partner is Museum Mathematicum from Gießen, the first science center devoted to mathematics, which was founded like 20 years ago, and they are. They have, I don't know if you managed to visit this museum.
You must.
Like 200 different exhibits, which are all built on this idea of communicating to the visitor what you should do with the exhibit. So it's not hard to understand, to conclude what is the idea. I mean, what you need to do with it, and it actually. It provokes a thinking process. So like having some questions, having ideas, validating those ideas and reaching that aha moment. So that's one of the main tasks that they are going to contribute to this process, because of course for the kids you have to make something that is going to be obvious for them. What should they do? So third partner is MACA. Guido, giving you.
Well, it's a no-profit association. The most important thing that I think it must be said is that this association is born from a group of teachers, and it was supported by the Federation of Teacher Society of Spain. That it's a very peculiar and important phenomenon, because in all the communities of Spain there is almost one association of of mathematics. And every 2 years there is a congress. This year in July there was a congress in a period in which in Spain all the congress were very, very poor of people, because a lot of peculiarity from, I mean, COVID, but also the virus that there are in the education departments that provoke that teachers can go easily to the Congress. But in any case, we were more than 600 teachers, professors from the kindergarten to university reached in Valencia in July to share teacher experiences. So educational experiences is still very important. That's a peculiarity. The rest of the thing you can see in the MACA page, and you can see what we do. But it's not something exceptional.
But I'm just going to add that they also have a magnificent collection of exhibits in museum, and they also do these pop-up exhibitions with suitcases, so that's their contribution to the project, of course. I mean, with experience. Next one is Fermat Science. So we have also a French partner. I guess people from France, they know that Fermat Science is trying to promote mathematics through the works and life of Pierre de Fermat, famous French mathematicians, but their expertise is similar to the expertise of all the other museums. So they have exhibits which are interactive, which provoke thinking, and they also organize a lot of workshops and different exhibitions and similar mathematical. I'm losing my words.
They are in a process of transformation of the materials, so it's very interesting what is doing there. We'll be there in 2 days just to give a look.
Next partner is from Cyprus, Citizens in Power, and they are actually contributing to this project with their experience in organizing projects, and also in this, let's say, important thing of resolving and solving challenges of education and environmental challenges. Do you have to add something?
No.
Okay. And last but not least, Mathematical Society Archimedes from Serbia, which are our main expertise is actually communicating mathematics to the teachers and to the children in the sense of different schools for mathematics workshops, competitions for mathematics, and similar ways to teach mathematics, and also with the publishing experience of the materials which are connected to all those areas of mathematical education.
And for the next matrix, we are waiting that they can have their own museum in Belgrade.
Hopefully.
So, that's all, I suppose, no? Okay. That's all, folks.
I'll steal one of the microphone. Are there questions?
Thank you. What is the suitcase? I know we have one of yours from a couple of years ago, yes, from Maca. What's your distribution? And I presume you produce these in multiple languages, or eventually you will?
Well, of course, the original idea, but there are many situations that have didactic suitcases. For instance, the Fermat Science also have their didactic suitcases. So it's not so original, the idea. The idea is take something to the schools. Yesterday we talked about the Seattle experience. They didn't want to put the mobile classroom. So the idea of the suitcase is go to the school or centers, social centers or wherever, but to make an exhibition is not a thing, material thought for classroom, can be adapted for the classroom. For that we selected, and that is, it keeps the same idea for didactic suitcase of SMEM, of the European project. Something that can go easily be moved in the situations, can be easily adapted for a classroom work because all the materials and the boards are easy to reproduce and cheap to reproduce. That is very important. And so, but the idea is to put up, to build a pop-up exhibition. So keep the idea of the way to propose from the no formal education. It's not something that is thought with a curriculum or thinking for classroom activity. So that's the idea. About the distribution, we have adapted as Maca. Now I'm talking as Maca. The suitcase that you have, for instance, can be requested by the Department of Education of Generalitat de Catalunya in a project that is called, that can promote STEM activities in primary and secondary schools. So they choose a group of schools that are piloting the project, and we produce adapted the suitcase for them. So we choose some of the material, especially the one that can be passing from one step, the primary step, to the secondary school with a continuity, saying how the material and the contents can be developed and make a continuum of education. Thank you. It's not organized.
Who drew the pictures of the animals? They are so beautiful.
They are open source, taken from Canva, because the project is open source, so we wanted to make sure that there are no problems with licensing.
I was wondering, how do you plan to distribute open source the physical exhibit? So are you giving instruction to replicate or files for give it to makers?
Exactly, we're planning on instructions, and currently we are in this phase of trying different materials and different approaches to this exhibit, Beaver's Dam. So in general, we want to make it accessible so that you can make it from different materials in accordance with what you have.
Both projects come with a guide, a user guide, a user handbook, so they can easily reproduce. Well, easily, it depends on you.
Hello, sorry for my English. I'm just, I think it probably the same in other countries. In France, we have a big problem with teachers that are in the little classes. They have problems with math, mostly. And the big problem for me is, okay, how do you make possible that they can really understand and make the activities alone? They need help, they need to be explained why it's interesting, how to do things interesting with this. There is a big problem with this.
Well, actually, it's a second part of the project in the sense that we first have to see what are we dealing with, and then we'll find a way how to communicate it to teachers. But in general, in this project, it has included this part of teacher training and materials for teachers. We plan to start with the teachers that are most eager to do some new things, because now speaking as Archimedes, we do have this like circle of teachers who are regular at our workshops and similar. And when you have like a base, when you have that I don't know, some small number of teachers which are going to adopt this, then then they are going to share with their colleagues, and then it's going to spread, hopefully.
And in any case, I think that there is a piloting time for all the products, so we can have a feedback from teacher, for group of teachers that we can choose, and usually for a territorial situation. I mean, it's easier to work with the school that you have around the museum, in which you have a relationship, consolidated relationship with the teachers. So and then it's very important to hear, and just the teachers, but also the children. A lot of messages, positive messages, came from the children. You have to be easy to adapt a lot your proposal, because for our experience, we are in general secondary school teachers, so we have not a personal experience of working with young children. So it's very important to hear them, but also to hear the children during the exhibition. That's the first work that the teacher have to do in the exhibition. Be very careful and stay for what they are doing, the children are doing, or not.
More questions? If not, let us thank Aleksandra and Guido again.
Thank you.
Our next speaker is Elena Mille from Passau Math Museum, hands-on mathematics by students for school kids.
Welcome to my talk about the Passau Maths Museum and our teaching concept, hands-on mathematics by students for school kids. So my name is Elena Mille. I work at the University of Passau, and my colleagues, so this is joint work with my colleagues Hella Epperlein and Brigitte Forster-Heinlein. So first about the Passau Math Museum. At the beginning, there was the intention to build a museum for educational purposes. So on the one hand side, there are education for the students of the university. For example, the university has a very diverse student body, so there's also teaching students and math students. And for both, the museum could be a place to learn how to transport mathematics. And on the other hand, there's of course the education for the school kids. So the new university or the museum could be a place to get in touch with maths at an early stage, but also get in touch with the University of Passau in this case. And like this, maybe encourage the people, especially educational climbers, to go to university and maybe even go to the University of Passau. So in 2012, the Maths Museum was founded, and one could say with a lot of enthusiasm, but at the time, no funds. As I said, we wanted to use this museum for education of students, so this brings us to the teaching concept, which is as follows. So the students, they develop instructive math exhibits. This is part of seminars or final thesis. And it's always in addition to the written seminar paper or thesis. Here you can see an example of a student who did an exhibit for the card game Double and its connection to projective geometry, and also a side of the page of the thesis. So, and next the Passau Math Museum comes into the picture, so it serves as the platform to present the work that the students do, and especially to present it visibly and permanently. So visibly also means that we put name tags on it, like you can see on the picture below, and permanently, so it stays there for a long time. The students can choose how to use the platform, so they can just put their hands on an exhibit or on an exhibit into the museum or on the website, but they can also be an active part, so they can be part and do guided tours for school classes, or be there and present their exhibit on open days, or maybe even give online workshops. So now the exhibit, it could be several different things. I brought some examples. So we have the physical device, like you can see on the left. There's an exhibit about Chladni figures, and here sand makes sound visible. Then it could also be an applet, like we see in the next picture. So here the student programmed an applet that uses the harmonic series to build a tower with the most possible overhang. Then the students could also choose to design a poster about a specific topic, like here about the curves of constant width, or maybe do a film. Like here, there's the example of a film about mathematical card tricks. And of course, there's many more, but these are maybe the main kinds of exhibit. So we implemented this teaching concept, and we saw the following effects. So the first one is that the students are very eager to get in-depth mathematical competence, so they make an effort to be able to answer questions from their peers, but also from the faculty or from the school kids. So they really dig deep into the subject. Then they also gain key competences like presenting in front of groups, or even groups with different background knowledge. So they have on the one side, they have the students, but they also have the school kids or many different backgrounds. They learn how to motivate groups, how to instruct groups, or respond to questions from the groups. And also they practice to speak mathematically, so just how to express yourself when you talk about mathematics. The next effect would be demarginalization in teacher training. So now we come specifically to teacher training. The students, they have their courses, the teacher students have their courses at the didactic department, but also at the maths department. And at the maths department, they do much less courses than the other pure math students. So they might feel like they're not as fit as the others, and they might feel a little bit on the side. But in this course, it's especially important. So their strength to communicate maths is what's needed and what's demanded. So they can shine here. The next point would be defragmentation in teacher training. So as I said, the departments are completely separate. So most of the courses don't have much to do with another. So there's the didactic part and then there's the maths part. But here in this setting, this comes together and merges naturally into one. And they see why they need the one and the other together. Then came the pandemic, and it also had an impact on our teaching concepts. So what we saw was that it was very clear that you have to be fit in digital formats of teaching. And in our experience, the students, they were taking it with both hands. So this opportunity. So I brought some examples. On the left, you see there's a student, the one who also did films about the mathematical card tricks. He now holds workshops online. And also he uses this opportunity to present his topic. Then the second one is a student who did a hands-on exhibit for the Prohistochrone, but then it was right then the pandemic hit and he decided, I will do something more. I will do videos for the website additionally. So he took the extra effort. And then on the right, we see two applets, and here, people just choose to do something online, and put it online. And for example, the one about the les ajouts, we have a les ajouts automata in our museum, and now we also have something for the online part of the museum. So the hands-on exhibit was done by somebody else, but now a student also decided to do an online exhibit for this one. So now about our latest developments. Also during the pandemic, we were able to expand our museum massively, which was thanks to two third-party funded projects. One was funded by the BMBF, which stands for Federal Ministry of Education and Research, and the other one was by the European Union. For example, here you see the film series, the logo of the film series. So we were able to, during that time, we implemented a film series that features films from our students, like about workshops or maybe just a film, like the mathematical card tricks. It's called Passau Mint Bonbons, which could be translated into Passau STEM sweets. Yes, so at the moment we are transforming from our initial educational museum into a museum that performs teaching and learning research. And our next step is that we want to evaluate the impact of our exhibits. The keyword here would be learning and education in museums. About the teaching and learning research. So each semester we choose a way to do evidence-based evaluation. We do this in joint work with Sima Kaspari. And for example, we did student-induced questions, confidence-based marking, and self and peer evaluation via rubrics. About the student-induced questions, so here the student who works on the topic and gives a presentation about the topic, they are asked to formulate two multiple choice questions, and we use this, the quality of the question that they produce, we use it as a measure on how well the student understood their own topic. So, for example, a question that is merely facts has a lesser quality in this kind of scheme than a question that needs analyzing or even creativity. So that's that. On the next slide, we see three papers that were written in about the teaching and learning research. And thank you for your attention. And now I'm looking forward to your questions.
Who wants to start?
For the teaching students to find a project, like, do you guide them in any way, or do they all come up with all these great ideas themselves? Because it's hard, right? We know that.
Yeah, and no, we give them a list of topics. So we have a large list of topics, and they choose. Well, they can choose their own, but nobody did so far. So they all choose one from the list. And we also give them sometimes a little bit of literature already with it, or some ideas.
Sorry, maybe you said, but it wasn't very clear to me. It's is this all education students or math students, or both of them? And if so, this is the first question. And the second question: how do you evaluate the success of the students' project in a way that is consistent? I mean, is it part of their academic work, and does it need to have a mark? And if so, how do you evaluate consistently?
So for the first question, yes, it's both teaching students and pure math students. So the seminar is open for both, and also the writing a thesis at our department is open for both students. And they get a mark on their seminar or thesis. And yeah, I'm not sure about the second part with the consistently, where we take into account the presentation, we can take into account, they also have the written paper, which is just normal written thing about their maths topic, and we also grade their exhibit. Is it easy to understand, or is it intuitive? Is it correctly just in what it tells? So these are the points that we look at.
Yeah, actually, my question was a little bit answered already, connected to how do you guide the students. Mm-hmm. But I really love this concept of connecting museums with the university in a way that the students create exhibits. So, mm-hmm. But you don't offer a lecture or seminar on math exhibits.
So how to
do one, like
no, okay. It's more cold water, and they.
Okay. That would be really nice. I mean, we still don't have the math communication lectures in our teaching. It's slowly starting, but the exhibit creation lecture would even be much nicer or same.
So we start a little bit with because we figured out you should think about maybe the 3 points you want to show the audience with your exhibit. So what's very important. So we try to start a little bit, but it's not really. Yeah, it's not really a lecture anymore. It's maybe 2 slides, so it can't be this.
Yeah. It's not a question, but just something to remark, because the idea of teacher training in the museum, I think that is very important. It's something that was in the communication from Seattle. They are trying to do that. We are in Barcelona an official teachers training situation. So it's, our training is recognized officially from the Generalitat of Catalunya. I think that is one of the goals that from the museum we have to try to obtain, because I think it's very important, the contribution of training for teachers that we can do from the museums.
Yeah, so, it's also
very good.
Yeah.
Try to have an official.
No.
Hello, thank you for your talk. I was wondering if the exhibits you produce, if they are open source and if you share them in any way, and also if you're interested in using other ideas that come from outside to reproduce others.
I think the code is kind of available just because it's on the website and you can look at it, but it's not, I think we don't have, I think it's not really open source, so it's not licensed, yeah. So it's just there and you can look at it and you could get inspiration from it and you could look at the code and...
I also mean the physical exhibits.
Ah, the physical exhibits.
Both.
So for a physical exhibit to be open source, there would be some kind of...
like a manual how to rebuild it.
No, we have not thought into this direction, also not put the work into formalizing this, the exhibits. So yeah, the students just build them and then they're there. So
thank you.
Thank you.
So is there any public record of how those are constructed? Are there papers published in some location that we could...
On the construction of the...
Yes.
I don't think so, no. I don't think so.
Okay.
So I think you talked a little bit about this, but it's not very clear to me how this is not a course, right? It's just a seminar, and it's not mandatory. It's like optional for the students. Can you talk a little bit more about like how a student would decide to take the seminar? Is it just a semester? Is it like longer than that? A little bit about the logistics, maybe about.
Yeah. So. Well, on the one hand, you can do the thesis, so that's also possible. But then there's the seminar, and the students, they have to choose a seminar, but it's not, they don't have to choose this one specifically. So they can, it's not like, it's a little bit mandatory to choose a seminar. And then, well, we just, they have a pool to choose from, and then they just decide which one they want. So we don't really influence them in any way. They just decide to, yeah. So we saw that at the beginning when we first gave, because it's not, well, at the beginning of the pandemic, there were very many people, and then slowly the people declined, or kind of a little bit declined, because I think it was saturated, because everybody who wanted to do this seminar and who wanted to build an exhibit was already in one of the years participating. So now we saw that, okay, for the moment, the need is not there anymore, so or the will from the students. But there were many students who thought, oh, is it held next year again, just to be sure that they can participate. So they know about it, and there were really some few single people who were very eager to get into the seminar.
Because you mentioned in one of your slides that they do these. They write a paper besides their like normal paper or something like that?
Yes. So, well, no, they do the exhibit besides the paper.
Oh, okay.
But the paper, in comparison to seminars from other departments or just other seminars, it's a little bit less. So we have like 10 to 15 pages from how much they have to do, and the other ones, they're bigger, they're like 30 pages. So from the effort, it adapts a little bit, but still, of course, it is, you have to put a lot of work in it. So probably you get a little bit above, but it's not the full paper and then the full exhibit.
Okay. And last question, how do you go about actually building this stuff? So like the thing that you were showing yesterday at the bazaar, I think you probably did it in like a laser cutter, and then the little lamps. How do you build that? Do you have like support for the students as they are building their exhibits if they require a little bit more, tools to make them?
So we give them budget if they want to build something which requires budget. And for example, well, they have many of resources at home. So the people who choose to do the hands-on exhibit and do this one that they do, they have friends or they have it at home, the stuff they needed. And I think this one, he went to a friend and he just cut the wood for him. And for example, the lamps, they're just, well, they have these little bases, and those were 3D printed. So we have access to 3D printers that they can use, but also we say we have access to them, and then they just print at home or somewhere else. So somehow these students, they have their resources, I don't know. But we do have, for example, 3D printers, and we have I think that we have, I don't know, Werkstatt, I really don't know the English word. Where they can go. So, but they don't really use it. Most of the time they find their own way to get to the resources. Yeah.
I have a question regarding the guidance you said you provided. So you said you give them a list of ideas they can choose from. So I said they've already realized many of these ideas.
Yes.
Do you keep coming up with new ideas? Do the students come up with some? Or do you think at some point you're going to not run out of ideas? That sounds impossible, but still have less for them to choose from?
We came up with new ideas, so we kept the list at, I don't know, 17 things to choose from, something like this. So we came up with new ideas, and also maybe threw out old ones that we thought, oh, thinking again, maybe it doesn't work. So each semester we updated them.
Each semester you have a full list they can choose from, and it's always pretty much the same.
But it was until now, well, that I know of, or I think it was 4 times until now. So with the list and everything. So
Hi, sorry about the other question. Another question from me. It's just I have set up a similar thing, like a course on math outreach and final year projects for students, and I had some challenges, so I was wondering how you cope with some of them, whether you had the same. So one of the challenges I experienced was how to framing it in the theory, which was kind of requested by my colleagues who take care of teaching. So did you have to frame this course in the theory, and how did you do that? And the second question is, sometimes what I struggle with is the turnover of students, in the sense that the students get very good at public engagement and they develop very good material, but then they leave. So in a way, there's a kind of turnover of students, a turnover of material as well. So what do you do? Do you are the exhibits that the students build in a way self-sustainable, so that you can use them again next year and in 5 years, or do you kind of change the material based on the turnover of students? Sorry, I don't know whether it was clear, but...
So the first part, I'm not sure, but I will start with the second part. So we use the exhibits we keep them in the museum. And also we as the ones who are working there and who also show this to the students who want to work there, we know the exhibit, and we also have the papers for it, so we can read about it, or we can give it to the instructors, the student instructors, to read about the background. And so the knowledge is just given from person to person. And so, yeah.
So in a way, the students who build the exhibit then train others to carry on once they left.
Yeah, or they train us and we train the next ones. Or yes, there are also students who come, who were in the seminar, who build an exhibit and who then work for us. But then they just know their own. But we show them the whole museum, and then they know all the exhibits, and then they keep on giving the information. So we just, we keep the student can leave, and we keep the exhibit and keep it visibly and running. The first part, I think maybe you can say it again, because I didn't really.
Or it's okay. I can ask you later.
Okay.
I'll catch you later. It's okay.
Yes.
Yeah, I think we'll take one last question, and then you'll have lots of questions for the coffee break.
Thank you. So very interesting. So a very, very short question. So which students are addressed this seminar? Just teaching students?
No, it's teaching
general?
students. It's also math students from bachelor and masters. Then we also have, I think, computational science it's called.
Okay.
So we also informatics students can enter the seminar. So it's... Yeah.
To make it clear. Thanks.
Yes.
Thanks a lot.
Thank you.
Our next speaker is Jorge Nuno Silva from Ludus and University of Lisbon to talk about the Fluid Math Museum.
Good morning. It's a pleasure to be here. Thank you for having patience to listen to me. I bring you some questions. I don't have many answers. And let me explain the context of my questions. I saw here beautiful things to promote mathematics, very well thought, very well engineered, but I think they mostly address the fact that we should make mathematics fun, and we should make people understand that mathematics is relevant in society. And I think what I saw here makes that in several ways beautifully. And I'm talking now about my organization in Portugal. I'm a professor at the University of Lisbon, but I have an association to promote mathematics called Ludus. And in these extension activities, we have, for instance, a very successful mathematical circus. This is us. We perform a circus show 100% mathematical. It's a big success, and the kids are fantastic. You probably know some of them. Tiago is very well known. And it's fantastic. We have been performing in Portugal in loads of places, in Korea, in the States, in England. Well, it's very successful. This is one way of doing things. Math, card tricks, string tricks, numerical tricks, lots of things, topological tricks, lots of things, everything mathematical, and at the end, if people have curiosity, we explain and so on. It's very nice. And we even had a van that the engine melted, but it was a beautiful van that we have. We organized the Recreational Mathematics Colloquium. I'm sorry, I'm making some publicity here, some marketing. I know that some of you already registered, but the others, if you don't know, you just registered. You'll be in January in Açores, a beautiful place, the island of San Miguel. This is the Gathering for Gardner Europe. You know, you all heard about Gardening for Gardner. It's a big show of mathematics and magic and so on that happens every other year in the States on even-numbered years, and on odd-numbered years, we organized in Europe. It's a fantastic meeting. Please show up there. Lots of things that I heard here are very much related to recreational mathematics, making mathematics interesting, fun, appealing, and so on. Another thing that I'm going to promote, I'm sorry, we added the Recreational Mathematics magazine, online, open access, peer-reviewed journal. It's very nice. And in recreational mathematics is kind of the journal. Of course, I have this thing for you with your cell phones. You all get there and see and download the nice articles I have. Another thing that I'm sorry. So this is the QR code for the journal. You are invited to submit and also to download lots of interesting papers there. Even John Conway published there. Okay. Another thing that we do and that I'm very proud of is a national championship of mathematical games. This is the name. But all the games are board games, mathematical board games, also known as abstract games. And this is the point a little bit that I want to address here. this is, in my view, more mathematics than lots of activities that we usually see in the promotion of mathematics. This is really rigorous, creative thought, abstract thought. There's nothing closer to pure mathematics, to problem solving, to those inner mind, inner intellect activities than abstract games. And so we have this is very successful. We have more than 100,000 kids every year participating. All the pre-university ages are allowed. We select the games. We use the Swiss system. Well, we kind of know how to do it. And in the final, we have around 2,000 kids, and it's one day. It's a fantastic day of activities and so on. These kids, maybe you don't realize, but these kids in first row, they are blind. And we have materials for the blind, and they play now with the visual kids, and we are also working with deaf kids, so it's also an interesting thing that we are doing. Just to finish up bragging about what we do, another way of promoting mathematics in a relevant way, for those of you that know Lisbon, you know that we have the traditional pavements in Lisbon made in two-color stone with drawings and patterns and so on. And we made a deck of cards with all the things that we can find in Lisbon in the following way. For instance, the two of hearts there shows a picture in Avenida da Liberdade of a place. And so the challenge is to find out where it is and what are the symmetries of this pattern. This is a paper wall pattern, so there are 17 of them. And then in the card, the same color, but the other suit, so the two of diamonds, you have the answer, it's in Avenida da Liberdade. You have the classification as the symmetries of the picture, and you have a little image that helps you with a special card that is a mirror to figure out how the symmetries work. This is another one. This is very typical in Portugal, this thing that tries to imitate the ocean. And it's so interesting because, as you know, there are 7 friezes, 17 symmetries of the wallpaper symmetries in 2 groups, essentially, CN and DN for the rosacea. So they all add up to 52 if you divide the problem cards and the answer cards. So it's perfect for a deck of cards. And we actually did this deck of cards, and now we did another one for the symmetries of the pavement in Açores. And so for those of you that go to Açores in January, you will be given one of our new decks. Let me just tell you something. From all the 7 friezes, they exist in sidewalks and so on. We have examples of all of them. In Lisbon, from the symmetries of wallpaper that are 17, we only have 12. And this is a cultural mark of Lisbon that only mathematicians can spot. Because the ornament changes. It can be a flower, a tree, a sheep, whatever. But the way it is propagated, only mathematicians can understand. And the school of these workers that make the pavements, they have these machines that produce the replication, and they don't know that they could have more. And this is similar to what happened in Mozambique, for instance, with the works of Paulo Guedes. I don't know if you heard about, you probably did, with those ornaments in the hats. He understood that the makers had their friezes, some other makers had others, and once he noticed that the hats were different, and he asked, where is Mr. Blah? He had died. So the new guy did not know how to do those patterns. So it's something about reality that an abstract concept actually helps. So I think it's a good idea. Okay. Now, we use here in this meeting the word museum in a very broad sense, like MoMAth. It's a museum. but I don't think it's a member of ICOM, okay? I don't know. ICOM is the International Council of Museums, and they just came up with definition of museum. This took ages, years, for them to decide. The definition is a disaster. I mean, it's a collection of words, but it's okay. It's okay. What I want to focus on is the following. A museum is supposed to do research, to collect, to conserve, to interpret, and open to the public, be inclusive, and they are supposed to offer varied experiences for education, enjoyment, reflection, and knowledge sharing. What I want to focus, I also work with the University Museum, a classic museum in Lisbon, and what should we do to promote mathematics in a classic museum? Because we differentiate a little bit between a museum, like an old school museum, like a British museum or something like that, and a museum like MoMath, that is closer to a science center, is these modern things, very technological, and so on. Let me give you an example. The Museum of Science in London. Do you know the museum? A few years ago, they changed the math exhibition, and they have now a very fancy surface there that is related to the turbulence of a flying plane or whatever. And about calculations, they have this abacus. It's a Russian abacus. The caption says that making calculations is important, and people use abacus. And 100 years ago or something like that. And then they have the plane, and then they have a big ship, and then they say that mathematics is very important also for the internet and so on. And I'm asking, is this an experience for the visitor? I mean, this is a postcard. I mean, I can buy a postcard with this abacus that is upside down. They didn't know, maybe, I don't know. It's a Russian abacus, and they probably don't know how to operate it, but it doesn't matter. But the approach is, it's kind of, this has an ideology. It's a way of doing things. And as you saw in the definition of museum, we have an obligation to the public, and the public is diverse. We have different ages, different cultures, different levels of education. We have people with learning disabilities. We have people that are illiterate. We have lots of things. And I think it's our obligation to build a museum that makes each person have an experience in mathematics. And to have an experience in mathematics is not to look at a postcard or not to look at an abacus. It doesn't even come with instructions. So my question for you is, suppose you want to have a room in the museum addressing arithmetic, calculations, numbers, sums, additions, subtractions, whatever. So should we start with pebbles, like the old guys? Should we show a replica? A museum is not obliged to have original stuff, can have replicas. So should we have a replica of the Shango bones and show how people kept track of things 20,000 years ago? Or, for instance, arithmetic from Babylonia. I know by experience that some people that go to the museum, when hears about this, and if they have the tablets and they can do tablets and learn base 60 and do calculations, they have a very good experience, a learning experience, something that they won't forget easily. Should I show them Egyptian multiplication? Is also very popular when people learn, because it's based on doubling, just doubling. The Egyptians didn't have multiplication table. They just doubled. They were very, they had good taste. Nobody with good taste enjoys multiplication tables. Everybody knows that. So they did very well. They built the pyramids without multiplication tables. My students love, for instance, learn to multiplicate and divide, do multiplications and divisions with the Chinese rods. Should we go there? Because, you know, some people like one thing, and get empathy with one thing, and some people don't. So we have to build all this. If I have South Americans, should I show the quipu, or should I go back to the early abacuses and calculation tables from Greece? Or to Rome, that built this terrible thing that made it's terrible because the beads, as you see, they are locked up in their rooms, and so you cannot just, like the pebbles, move them around easily. So, I mean, this is portable, it's very nice, but the theory of it is terrible. Should we go to things that are actually even a little bit mysterious from South America? Nobody knows exactly how this works, but people believe it is an abacus. And look at it, it's beautiful, it's mysterious. So should we go this way? Or should we go to traditional, this is a Macau Chinese abacus. So we have lots of them in Portugal because of Macau, that used to be Portuguese. And what about the Japanese abacus? It's a different story, Japanese abacus. Or Gerbert abacus, for those of you that never heard about it. Gerbert, the Pope Sylvester II, he invented a fantastic abacus in which the beads carry numerals. And so it's a confusion, it's very confusing, because if you know numerals, you don't need an abacus. You just need pencil and paper. But he didn't learn very well the pencil and paper, but he had contacts with the Arabs in Catalonia. And so he built a fantastic thing. He was the only one in Europe able to make multiplication of large numbers. And that says a lot. Or should I teach these things? These things are always popular, and they bring an attachment. The people, when they like these things, when they like to learn, when they like to learn how to do this Gauss division, they actually start thinking about the operations, the arithmetic. There are lots of questions. The context is very, very rich. And of course, Napier, these are Napier's bones, they are well known. Not so well known. This is actually the Gauss, this lattice multiplication implemented in little sticks. But not so well known is this abacus by Napier that is fantastic. It's just a checkers board. And he built it, he invented it also because everybody had a checkers board at home. So everybody could do calculations with this method, which is beautiful. Addition and subtraction is trivial, multiplication is beautiful, division is a little bit more difficult, square roots is tough, but it's doable. It's beautiful, it's just beautiful. Some people like machines. We can show the Pascaline. Of course, I'm being a little bit historical because it's a museum that I'm talking about. So it's not just creating things. I have to relate things to the past as well, and to the nature of the subject I'm talking about. So I can talk about slide rules, and I can talk about modern calculators and so on. But what I propose is that we introduce here conceptual things in the form, for instance, of problems. This is a very well-known problem. I think you all know this problem. I'm trying to choose a problem that is relevant in the context of arithmetic. Is there anybody that don't know this problem? The heritage? So, okay, I'll say it very, very fast. A father dies, he has 17 camels, and he has 3 sons. He leaves 1/2 for the oldest, 1/3 for the middle kid, and 1/9 for the youngest kid. 17 does not divide by 2 or 3 or 9. So it's a disaster until a guy comes and he offers a camel to the lot of 17, becomes 18, everybody is happy, and 1/2 of 18 is 9, and 1/3 is 6, and 1/9 is whatever it is. Everything comes clear, and what is the problem? What happened here? You need to think a little bit about the numbers and to find. I don't tell you the solution because I'm a mean guy, so that's all. We should introduce also traditional problems like this one of the legend of the creation of chess. There's lots of intuition here to gain with the exponential growth. And also these little teasers. This one I'll explain, maybe there are even more people that don't know this. Three friends go to a restaurant, the bill is 30 euros, they pay 10 each, but the waiter realizes that he made a mistake, it was 25, the bill, so he brings 5 euros back, but he sees that the guys want to divide evenly, so to save them work, he steals 2 euros and gives 1 euro to each of the customers. So each man paid 9 euros, plus the 2 euros that the waiter stole makes 29. It's 1 euro missing here in this story, right? It's missing, so you find it and you give it to me later, okay? So it's also interesting, it's also related to the numbers. You need to put your mind around this, the nature of these numbers. And of course, games, traditional, again, by experience in Portugal with the immigration from Africa, there are lots of cases in which the students don't even talk to the teachers. They don't even change words until, and I made this experience, I told the teacher to take Mancala to the classroom. And then they all start talking, they never stop talking. And they shared the rules, and they played with each other, and they taught to the teacher, and whatever. And this is pure arithmetic, this kind of Mancala game. But I propose another game, an example of a game, one of our abstract games. I'll tell you very quickly how this is played. There are 2 players. There is a board that starts empty, and on each turn, a player places 2 pieces on empty hexagons. The thing is, he can place 2 pieces of any color, 2 blue, 1 blue and 1 red, or 2 red, even though 1 player is blue and 1 player is red. At the end, the board is filled, and we compute the number of pieces connected in each group. In the 2 largest groups of each player, the cardinalities are multiplied, and that's the score of the player. And higher score wins. The thing is, if you are greedy and you have, for instance, 2 big chunks of pieces, your opponent that can play your color can connect them, and then you are down to 1 group and your score is 0. So this is one aspect of the game that is very interesting. Another is, if a player has a large group and a small group, where should he play next? Should he add to the big group or to the small group? Okay? Usually, kids, when they start playing, they go and make fatter the fat group. It's wrong, because each piece put there gains the cardinality of the smaller one, because it's a multiplication. So there are lots of things to learn by practice, and this is hands-on, and this touches the concept. And of course, NIM is also a good game, not so basic. You all know NIM, I think. I'm done, right? Okay, thank you. Thank you.
So we'll take a few short questions.
Thank you very much. It's like an overwhelming amount of good ideas in one talk. So I will ask about National Championship of Board Games. So do you have like a list of games with rules somewhere to be able to do it in other countries? Yes. And do you know also if it exists in other countries, how original this is?
I know that a few years ago, a country that I will not name went to my homepage, copied everything, and implemented the championship without telling me anything. But it's okay. I don't mind. But I put here the URL, I think. This will take a while. We have everything there online. Everything. Oh, I didn't put URL. Oh, yeah, it's there on top. Everything is there. We change the games a little bit from year to year. There are 6 games on each championship, and we try to change one every year. And the schools have 3 levels of ages, or 4 levels, I forgot. And each level can choose 3 games. And we admit each school can take 1 kid for each age level for each game. So each school can take 12 kids. And this is amazing. This works very well because the teachers like this, and so they help. And we have also some teacher training, official teacher training on games where I teach them, me and my colleagues, we teach them how to organize these tournaments, because it's something that is difficult for the teacher. He has 30 students or 20 students, wants to make a tournament. If he doesn't know the technique of making a tournament, and he does what we call the cup, like the cup, the soccer cup, that the one that loses gets out, doesn't play anymore. That's terrible. We cannot keep the order in the room. But if he learns how to do the Swiss system, like the chess tournaments work, then every player plays the same number of games, and it's beautiful. Everything works well, and it's fair, and it needs a number of rounds about the log 2 of the number of players, and so it's very, very economic.
Hi, thank you
Hi.
very much. This is really interesting. I'm wondering about things that are very recently obsolete to keep our eye on. We have students and things that we used to rely on as a teacher. We could talk about this thing and everybody understands, like a balance scale. Nobody's seen one. Money, we used to have something where you needed a coin. 6 years ago, 7 years ago, everybody had a coin in their pocket. No one has a coin in their pocket. They don't, it's a picture on the cash register and scan your card. So we're sort of approaching those like we would Napier's bones, like this old thing. And I'm just wondering how we keep up with the things that we've lost as points of contact for teaching. Map reading has totally changed. It starts with you in the middle of the world, not, the map. We used to use camera aperture and shutter speed for inverse proportions, and nobody knows what that is. These are things my children knew about, and I'm not that old, but yeah, just to identify the things that we're losing, and how can we make up for that?
Well, for instance, the balance scales, we have lots of problems of balance scales. They are beautiful problems. We have also online, and we actually build some balances, and we have weights and so on. We have a few big in wood. They are not very practical, but we have at the museum. We have. But of course, things that disappear, they just disappear. I mean, we have to kind of adapt, but the last thing we built for the room of the museum was a nice table with the Königsberg problem with extra bridges and a rope. Well, things have to be resistant for the kids and so on, right? So, and another with crossing the river puzzles, like those Alcuin things, but more elaborated with several versions. It's the goat, the cabbage and whatever, and the jealous husbands, whatever, and then with an island in the middle and so on, more and more complicated. So it's not difficult to do, and the kids like to touch things, the kids and the adults, of course. But we have to build them. We have to be creative about that. And of course, if you can do a decent job electronically with those computers, I don't know, but some people do know how to do that.
So I'll postpone the rest of the questions to the coffee break that we're taking now, and we're resuming earlier than before. Oh, you didn't say that before. Okay, so break, and we resume at 11:20 with the plenary talk from Team Chartier, and thank you very much again.